So this video I'm calling a bonus video. In other words, this video has got some important proof in it that you probably want to watch and learn, but you can also save it for a time when you have a little bit more time if you're not particularly interested in it. And this is the proof that the angles of a triangle sum to 180 degrees. So not only can we do that little experiment that we did with cutting up triangles to confirm this, but we can actually formally prove this with a two-column proof. But before we do, we have to discuss the parallel postulate, which is something we're going to have to assume if we go ahead and try to prove this. A parallel postulate is necessary in Euclidean geometry, and it states that given any straight line and a point not on it, there exists one and only one straight line that passes through the point and is parallel to the given line. Okay, so in other words, if we have some straight line, let me just draw a straight line as an example. Let's say this is our straight line. And then we have a point that's not on a line. Then there is exactly one and only one line that we can draw through this point that is going to be parallel to the given line. Let's say that is the line. Okay, it also implies that we can always draw this line, so that wherever we have a point not on a line, we can always draw a line through the point that is parallel to any other given line. So let's see what that means and how that helps us in terms of trying to prove that the angles of a triangle add up to 180 degrees. Let's take a triangle like this, okay, and let's say that we call this side A, B, and C, and so we've got angles. We'll call this angle A, angle B, and angle C. Okay, good. And now we want to try to prove we're given triangle ABC. And to prove, we have to prove that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Let's do it. So statement and reason. First, we have our given. We have triangle ABC. It's given. Now we're going to use our parallel postulate. We said that any point not on a line we can use to draw a line through it parallel to a given line. So let's take a look at line AC, and let's go ahead and let's draw a line through B. Let's call it line D. Okay, and let's make line D parallel to line or line segment AC. So now I'm going to say that line D, which is drawn through B, is parallel to AC. How can I say that? Because of the parallel postulate. Okay, so I have just drawn a line through B that is parallel to AC, so I can write these parallel bars next to that triangle side as well as next to the line D. So if I know these two lines are parallel, then what can I conclude? Well, I can conclude a lot of things about angles that are formed, right? Angle A here, and let me number these angles 1, 2, and 3 up here so that it makes it easier to refer to them. Angle A here, and I'm going to extend this out just a little bit so you can see that we're dealing with some transversals here. Angle A is congruent to angle 1 over here because they're alternate interior angles. Okay, so we can say that the measure of angle A is equal to the measure of angle 1 because of the alternate interior angle theorem. For the same reason, we can say that angle C, which is in here, is congruent to angle 3, also because of the alternate interior theorem. Those two angles are congruent. So the measure of angle C equals the measure of angle 3, also by the alternate interior angles theorem. Well, let's see what this is telling us. Is there anything that you see about this picture that gives you an insight into what's going on here? Because take a look at this. This is a line, right? So we're talking about line D, and we can easily see that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 adds up to a straight angle, right? Because these three angles all together add up to the angle made with vertex B along the line D. So we can say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 add up to a straight angle. And that is because of the definition of a straight angle. And also we can say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180, because that's also part of the definition of a straight angle. So we know now measure of angle 1, this is very important intermediate result, plus the measure of angle 2 plus the measure of angle 3 equals 180. But we can use substitution now. The measure of angle 2 is angle B, right? That's an angle of the triangle. So we could use substitution to substitute angle B in for angle 2. We know angle 1, measure of angle 1 equals measure of angle A, so we could substitute in the measure of angle A instead of the measure of angle 1. And what about the measure of angle 3? Well, we know the measure of angle 3 equals the measure of angle C. So we can now substitute in here the measure of angle C. And what do we get? Measure of A plus the measure of B plus the measure of C equals 180? Well, we did this all by using substitution 3 times. And look what we needed to prove. That was exactly the statement we needed to prove, okay? We wanted to prove measure of angle A plus B plus C equals 180, and we've proven it. So by using the parallel postulate, by using the alternate interior angle theorem a couple of times, the definition of a straight angle, and substitution, we have been able to prove in a 2-column formal proof that the measure of the sum of the measures of the angles of a triangle is equal to 180 degrees.